The following video shows you how to make this animated text with geometry nodes in Blender. Hello, this is what we're making today. A geometry node group that mixes through a list of strings, creating animated outlines. As you can see from the graph editor, there's only one keyframed channel. This slides us through the list. Everything else is automatic. You can use this with any font that you can use to make text in Blender, including wingdings, dingbats, or wombles. This tutorial probably isn't for beginners, but if you've finished your donut or just watched any old tutorial really, I think you'll probably get something out of it. For those of you who just want what this thing has got, there's a link to our Gumroad in the description where the node group can be found waiting. Before we embark on this pause and rewind adventure, you want to make sure that you have the Node Wrangler add-on enabled. I use it a bit, but definitely not as much as I should. Okay, that's the introduction over. Good luck, everyone. First, we're going to select the cube and apply a Geometry Nodes modifier to it. Open the Geometry Nodes editor by pressing Shift F3 3 times, then Home key to frame all. Shift A, then S, and we're going to add a String to Curves node. Add a word, then with the cursor in the viewport, press 7 on the numpad so we can see what we're doing. Center our word and line up our view. Okay, so we want the string to come from an input into the Geometry Nodes group. Rename it 0, duplicate it 5 times with the plus button and number each one. 1, 2, 3, 4, and 5. Let's fill these strings out with words that match the numbers so we can keep track. It's okay, you can look this up. Duplicate our 0, and then change the data type to float. This is going to be our line control. We're going to use it to switch between the strings. To do this, let's plug it into a compare node. Change the input type to integer and, hoping no one noticed, plug it back in. Now I'm going to add a switch. Change it to string before connecting the result of our compare node, plug 0 into true and the string output into our string to curves. Now, sliding our line input, we see that we get the 0 string if the value is between 0 and 0.99999. Otherwise, we get the false result, a blank void of nothing. Ctrl-Shift-D to duplicate these nodes with their inputs. Swap the string for string number 1, then join the two switch outputs with a join strings node and plug that into our string to curves. Change the new compare node to match the string number. And now, if we slide the line input between 0 and 1, we get the corresponding string. Let's repeat this for all 6 lines. Look what I made. 5 compare and switch nodes in a group with the join strings node. I made this by selecting all of those nodes and pressing Command G, then press Tab to exit. I've even renamed it. Now we can test if it works. Which it does. In order to mix between each string, we'll need both the current line and the next line. So we will select these two nodes, Ctrl-Shift-D to duplicate, then Ctrl-Shift with the right mouse button to join the two outputs. It may look like we just have one set of curves, but it's actually 2 made from the same string. Adding 1 to the line input for the second line fixes this. Now we get the current line from the top group and the next line, the line we want to mix to, from the bottom. So we've got 4 current and 5 next. Each has 4 instances, 1 for each letter, remembering that a letter can be made of more than one spline. A realize instances node gives us 6 splines with 42 points for the 5 and 5 splines with 47 points for the 4. We want to sample the position of all of these points, so let's add a sample index node, set it to vector. For the value, plug in a position node, and to get a field of vector positions for every point, we're going to use an index node. Shift D to duplicate this, then connect it to the second realize instances node. Now, using a mix node, we will take the position vectors from the current line and mix them with the position vectors from the next line. We're going to need some splines to apply this to, so let's create a curved circle. Add a set position node and plug our mix result into the position. And we can see that we've got something, but it's not anything you'd make a YouTube video about. Why is this happening, I hear you cry? Well, the circle is just 1 spline with 32 points, while we've got 5 splines with 47 points for the 4 and 6 splines with 42 points for the 5. So the first thing is, we need more splines. Add a duplicate elements node and set it to spline. If we bump that all the way up to 10, the result is better, but it's still not right. Mixing between the two, we can see that some of our circle splines are being positioned to more than one letter. This is because the number of points in each letter spline and the circle splines, well, they're not the same. But I think I can fix this. Let's change the resolution of our circle curve to 80. And we will add a resample curve node after the realize instances node on each line, also setting the count to 80, which actually applies to each individual spline. And look, it works. The resolution of what we are mixing and what we are mapping to is uniform, and it looks great. I just can't seem to tear my arm. Shift D to duplicate our group input, then take the line input and add a math node to it. We want to isolate the fractional digits, the numbers after the decimal point, so we're going to get the floor, which is the number rounded down, and subtract it from the original value. Now plug the result into our mix factor. Our isolated fractional digits now drive the mix, so sliding the line control blends harmoniously between our 5 strings. Some time-lapse tidying, because a tidy node tree is a tidy mind. We're going to add a vector math node to our mix result and change the type to scale. We are going to drive this with our isolated fractional digits so we can create an automatic popping motion with every line transition. Connecting directly like we have the mix factor, we can see that the scale matches the factor going from 0 to almost 1. But if we map it to a float curve, we can control the scale at any point in that range. Change the max clipping on the Y to 2, then reset curve to refresh it. Select the first point and change its Y to 1. Then click on the middle of the curve and drag this new point up. Now when we slide the line value, we can see that the scale matches the curve, growing in the middle of each transition and then returning to 1. We actually want the blow up to happen twice, at the start and at the end, giving us a popping feel. So let's move this point back and to the left, and then add a few more to make a pair of knolls or small hills before doing a little tweaking, but not too much because a person can lose themselves tweaking. Scrub through again, and now we have two jaunty little bouncers. You noticed that I didn't set the minimum input value to 0, so I can't drag past it, didn't you? Well, I have now! So we actually want the first pop to happen before the mix starts, so it feels like the pop is initiating it, and we want the second pop to happen immediately after the mix to accent the new line. This is what this map range node is for. If we set the from minimum to 0.1, the maximum to 0.9, and leave the 2s at 0 and 1, the mix won't start until an input of 0.1 and be complete by 0.9. Boy, was that hard to explain. But it would have been even harder if I'd actually explained it. I'm going to tweak the float curve a little bit more. But don't worry, I know my limits. Scaling down in the middle will accentuate our bumps. Let's set some keyframes so that we can properly see how all these things work together. Click between these two panels and select horizontal split. Place it down here and Shift F12 to change to the timeline. We'll be transitioning to each line over 10 frames and then hold it for another 10. We'll do this for each line. I've sped this up because ironically time is the enemy of us all. When that's done, set the timeline end to 100 and press the spacebar to play. We should probably make this bigger. I changed line 5 to 0 so that we can loop forever and ever. And it looks pretty good. I'm still not happy with the pop though, so back to the flow curve. My friends used to say that I was never happy, but they don't anymore because they've abandoned me. Now look at that. It's got much more punch. The last thing we want to do with our pop is add a way to dial it in and out, because who doesn't like being in control? Another duplicate group input, and connect a new input to a new mix node. Rename this pop and move it to just below the line control. Plug the output of the float curve into input B, make input A 1, then connect the mix result to our vector math scale node. And now you can adjust the pop to taste. Congratulations. Let's make a little room at the end of our node tree because we're going to make some mesh tubes and you'd be mistaken for thinking that I planned ahead. Add a curve to mesh node. For the profile curve, we're going to attach a curved circle. Make the radius 0.008 and the resolution 4. This is going to reduce the poly count significantly, but also make our tubes quite flat. So let's add a set shade smooth node to fix that. Next, we are going to set a material with a set material node. Select the default material. We're not going to touch the base color. Instead, we are going to change the emission. Make a nice orange yellow. Checking that with viewport shading. Great. And finally here in our tubes masterclass, we need to make sure that our meshes are evenly distributed. So we're adding a resample curve node and resampling by length. Now we have tubes, we can set sail on our funky tube adventures. Make some more space and add a set curve radius node. Make that 1 so it doesn't disappear, and add a random value from 0.7 to 1.1. If we push the seed around, we can see that we have a little bit of wiggle. A very little bit of wiggle. So let's make the minimum 0.65 instead. Yeah, that's a bit more obvious. Now we're going to drive this value with a scene time node using the frame output. We can see that we're at frame 80 and seconds 3.333 thanks to our tireless tooltips. Back to the timeline where we're going to adjust playback to between frames 90 and 120. This will give our radius noise the chance to shine on its own. And now we can really see its lovely little rippling, its pulsating noise. Shine on, you crazy radius noise, shine! When we come to render, we won't want this noise to have motion blur because that'll just look like fuzzy sausages, so we're going to prevent that by rounding the frame value with a math node. We'll be doing this again, so keep score of how many times you notice and we can tally up at the end. Add a noise texture node. Change the type to 4D and plug the value from our round math node into the W. We're going to duplicate our pop set position node, placing it after the resample curve and plugging the color from the noise texture into its offset. The technical term for what we have here is too much noise, so let's bring it back to the center with a vector math node. At the moment the noise is giving us offset values of 0 to 1, pushing our geometry up and to the right, so if we subtract 0.5 from each of the values, the noise is centered. Now another vector math node, this time multiply. Seeing as I'm only looking at this noise in 2 dimensions, I'm going to zero out the Z, but 0.025 for X and Y. Pressing the spacebar, we can see that the noises combine to give us this very satisfying shimmer. The last thing I want to do with this new noise is add some directional control. Duplicate the group input, and now we're going to add a combine XYZ node. Plug the X and the Y into the group input and our vector into the multiply math node. 0.025 into our 2 new controls, and let's rename them X tickle and Y tickle. Because, you know what? There's just not enough whimsy in the world. Now we have full control of the noise in either direction, which allows us to create a variety of different noisy looks. This time I've done my tidying off screen, so we can push the nodes from the last section out of the way, then duplicate this random value, making the min-max -1 and 1 respectively. And we'll plug that into a math multiply node, multiplying it by 0.02. Then we can take the result of this and, using a vector math node, add it to our tickle noise vector. So far, so terrible. Let's restrict this to just the y-axis by duplicating our combine XYZ node. Budge these over so we have a little more room. We want our random value to change with the frame, so let's plug our rounded frame number into the seed. This time, however, we want every point on the same spline to have the same random value. For this, we'll use a curve of point node to get the curve index of each point and set this as the random value's ID. Now, each curve jostles up and down, which would be a good name if we were in the business of naming things. Yet another duplicated group input which we connect to the multiplying math node. Let's rename it our new favorite word. And let's move it up so it can be with the other cogs in this beautiful wobbly wiggly machine. Zero has 6 splines and 1 has 5. So, as we scrub through, you can see that spare spline making its lonely way to the origin. This is because there's no position data for it. Its purpose has been morphed away. But we can fix this. Back to our node tree. Ta-da! Yeah, it's tidy again. I thought you'd notice. Let's make some room between our two position sampling lines and some space after our realize instance nodes. Add a join geometry node, shift right mouse button to add a reroute, which stops this second connection from blending with the first and allows us to add a third. Now we duplicate that so we can add one on the bottom too. What this, albeit slightly hacky bit of wiring does is ensure that there's always enough position data for the splines to be mapped to. And before people start yelling in the comments section about the duplicate elements node, I tried that. It doesn't work. It messes with the index order of the curves. So please don't judge me because I already do enough of that for the two of us. Anyway, do you see how the letters are now made up of too many tubes? That's because all 10 of our curved circles now have a letter to map to, and seeing as each curve has a unique amount of jostle, the duplicate letters don't line up. You may have noticed that I've been adding nodes, 2 domain size nodes and a math maximum node. This compares the number of splines in each line and outputs the largest of the two. Plug this into our curved circle number and now we have just the right number of tubes, because the math maximum node is calculating the exact number we need at any given time. Playing through, we can see that this solution is mostly successful. But we still occasionally encounter the too many tubes problem. This occurs when we're holding on the line and the next line has more splines. You can see it here clearly with the 2. To fix this, we are going to take our mix factor driver and add a compare node, comparing it to 0. And we're going to use the result to control a switch. True, the number of splines in the first line. False, our calculated maximum. And that is it. We have finished. All that there is left to do is render this thing. I would show you how to do that, but if I've learned anything in this world, it's if I give you everything, you won't come back. So here it is, our geometry node group, and the fruit of our labours? Tubes. Just watch them go. A cosmic tango of symbol and meaning, wiggling wires of whirling words, tales from typographic oceans, fonts of hope in a barren world. Thanks for watching. I'll be back soon.